Okay, we are going to be starting in on trig stuff now, and we'll be doing trig for the rest of the semester. Chapter 6 is where the trig information begins. Now, just like with the algebra, the idea is that you've seen this stuff before, and it's good to recap, the main points here going into a pre-calculus or a calculus class, since you'll be using it. I tell my calculus students trig is very, very important, just like algebra is very, very important. Students struggle in calculus because they struggle with the basics that they did not learn in algebra and trig. So it's super, super critical that we understand the basics when it comes to this stuff. 6.1 is just some introductory stuff with angles. A lot of what we do in trig has to do with the circle, okay? And of course, I'm going to assume that you know the basic information about a circle. A circle has 360 degrees. One complete revolution around the circle would be 360 degrees. And I've got these four major axes labeled in degree measure. When we work with angles, an angle with a positive value will indicate a counterclockwise motion around the origin, and an angle with a negative value will indicate a clockwise motion around the origin. The angles are typically denoted by Greek letters. Here's some of the common ones: alpha, beta, gamma, theta. So in calc, you'll be doing lots of things with angles, and these are the symbols that primarily are being used to denote an angle, although sometimes capital letters are used. I believe that this book uses capital letters, although they used to use the Greek letters. At some point, you should probably have a look at the Greek alphabet if you plan to continue in math. Obviously, you guys are planning to continue in math by taking calculus, and you'll be doing things with Greek letters. So at some point, it might be just a good idea to see what those letters are. Anyway, okay, so I've got some examples where I'm just graphing an angle. So if we have a 225 degree angle, here's 0 degrees, 90 degrees, 180 degrees. 225 degrees would be between 180 degrees and 270 degrees, right in the middle actually, and so I've marked that there. I've gone in the positive direction, that is counterclockwise around the origin. A negative angle means that I'm going clockwise from the origin. So here'd be the 0 degree axis, here'd be the negative 90 degree axis, which is the same as the 270 degree axis. Here would be a negative 45 degree angle, which would also be the same radial line as a 315 degree angle. Okay, and we'll talk about radian measure later, but in this next problem, okay, if we have a 405 degree angle, one complete revolution around the circle is 360 degrees. If I go another 45 degrees past that, then I'll be at a 405 degree angle, and that would also be the same radial line as a 45 degree angle would be, only you've made another revolution around the circle there. Okay, I'm using theta to indicate the angle that we're describing here in the problem. The next thing that we need to know is how to convert an angle in degree measure to degrees, minutes, seconds form, and then vice versa. So here's 1 minute. This is the symbol for minute, is 1/60th of a degree. 1 second, this is the symbol for a second. 1 second is the same as 1/60th of a minute, which is the same as 1 over 3,600 degrees. 1 degree is the same as 60 minutes, and 1 minute is the same as 60 seconds. So there's a couple of problems in this section where they'll want you to be converting things to degree decimal form or degree minute seconds form. So let's take a look at this example. We have an angle that is measuring 74 degrees, 8 minutes, and 14 seconds. Okay, what would that look like in degree decimal form? Well, 74 degrees, 8 minutes, and 14 seconds is the same as 74 degrees plus 8 minutes plus 14 seconds. So if I split up those three individually, Now, 1 minute is the same as 1/60th of a degree, and I'm trying to get this all into degree measure, decimal degrees. 1 second is the same as 1 over 3,600 degrees. Okay? And so then I would go to the calculator. 8 times 1 over 60 would be 0.13 repeated. I've rounded to 4 digits there. And then 14 times 1 over 3,600 is 0.0039 if you round to 4 digits. Adding all this together means that we would have a degree measure that is 74.137 degrees as the answer. Okay, going the other way, suppose that we have an angle that is 34.815 degrees, and we want to change that to degree, minutes, seconds form. Well, 34.817 degrees is the same as 34 degrees plus 0.817 degrees. 1 degree is the same as 60 minutes. Okay, and so if I multiply 0.817 times 60 minutes, that would be 49.02 minutes. And 49.02 minutes is the same as 49 minutes plus 0.02 minutes. And 1 minute is the same as 60 seconds. So 0.02 minutes would be the same as 0.02 times 60 seconds, or 1.2 seconds. And when you combine this into a degree, minutes, seconds form, 34 degrees, 49 minutes, and 1.2 seconds is the angle that we're describing there. Okay, the next thing I want to talk about is radian measure. So there's 2 common measurements for when you're talking about angles. That's degree measure and radian measure. It says that if the radius of a circle r and the measure of the arc made by angle theta is also r, so the radius is the same measure as this arc here, then the angle theta is defined to be 1 radian. Okay, so I've got a picture of what 1 radian would look like if you were to draw that. The arc length for angle theta in radians is where you take r times theta. S is what they're using for notation in the book for arc length. Now suppose that we had an entire circle. Okay, the entire distance around the circle would be the circumference, right? So the arc length around the entire circle would be 2 pi times the radius, which is also the circumference of a circle. If I set 2 pi times the radius equal to the general formula getting the arc length, then solving for theta, you want to divide both sides by r, you have theta equal 2 pi radians. Okay, now what that means to us is that 1 complete revolution around the circle is 360 degrees, but that is also the same as 2 pi radians. Half the distance around the circle would be 180 degrees, which would be pi radians. Okay, now in this equation here, if I were to divide both sides by 180, 1 degree would be the same as pi over 180 radians. And if I were to divide both sides of this equation by pi, 1 radian would be the same as 180 divided by pi degrees. These would be the general formulas that would allow you to change from degree mode to radian mode and radian mode to degree mode. You'll want to make sure that you know that. Now, there's kind of a mix of the units that they'll be using here in the book. I mean, some of the problems are going to be where you'll be given answers in degree measure, and some of them will be where you'll be given answers in radian measure. Be sure that you pay attention to the directions and how they want the answer represented. Okay, I feel like they are very clear about that in the book. Now, if you're not told, always assume that you're in radian measure. Okay, when you're working a problem. In calculus, most of the problems that you would ever work with angle measurements and trig are going to be where the angle is in radian measure. So consider that when you get to calculus, that is going to be the case. All right, so in this next example, I want us to get some practice converting an angle that is in degree measure to radian measure. 45 degrees, well, 1 degree is the same as pi over 180 radians. And so 45 divided by 180, that'd be the same as 1/4. And I've still got pi there, so pi over 4 radians would be the same as a 45 degree angle. If you have a 60 degree angle, again, 1 degree is the same as pi over 180 radians. And by multiplying those numbers, 60 over 180 is 1/3. And so a 60 degree angle would be the same as pi over 3 radians. And by the way, whenever we have an angle that is in radian measure, you can write radians or not. If you don't write radians, it's understood to be in radian measure. Okay, so 60 degrees, that's the same as pi over 3. You know, you don't have to write the word radians. Usually we don't, once we start doing some more with this stuff. 90 degrees is the same as 90 times pi over 180 radians. 90 over 180 is 1/2. So pi over 2 radians would be that angle. 150 degrees in radian measure is the same as 5 pi over 6. Now, of course, you'll want to reduce the fractions when they reduce, simplify like you would anything else in math as far as you can go. Okay. By the way, one of the things that I wanted to mention here also, if I just briefly go back to these problems where I was drawing the angle here on the unit circle, or the circle rather. So I'll talk about the major angles and then the minor angles. The more that we do with this stuff, the major angles, the major axes, are these 4 angle measurements here. Okay, and this is in degree measure. And then we've got the minor axes, okay, which would be all the other angles that are not the 4 major axes. Okay. We also have some common angles. There's going to be angle measurements that come up over and over and over and again, and they're common angles. And you'll see that as we go along, what the common angles are going to look like. Here's an example. I want us to convert each angle to degree measure. So pi over 6 radians. 1 radian is the same as 180 over pi degrees. And the pi's will cancel there. 180 over 6 is the same as 30. So 30 degrees is the same as pi over 6 radians. 3 pi over 2 radians in degree measure. The pi's will cancel there. 180 over 2 is 90. 3 times 90 is 270 degrees. And then negative 3 pi over 4 radians. When you multiply by 180 over pi degrees, the pi's will cancel. 180 over 4 is 45. Negative 3 times 45 is negative 135 degrees. Now, you want to make sure that you know how to convert back and forth, okay? Because there's going to be some problems where you'll be given some information in degree measures and they'll want the answer in radian measure, or vice versa. Okay, so these would be the 2 conversion formulas to know if you were going to interchange between the systems there. The last thing that I wanted to mention is just a formula here. Area of a sector of a circle is 1/2 times r squared times theta. Theta is in radians. Okay, and there's a couple of problems towards the end of the section here where you're going to be computing the area of a circle sector. One of the problems that I liked was on page 372, problem 95. If I get the book here real quick, we can look at that. Problem 95, it says that a water sprinkler sprays water over a distance of 30 feet while rotating through an angle of 135 degrees. What area of the lawn is going to receive water? Okay, so they give us a picture there of what would be a circle sector, and they want us to find the area of this sector. So the formula that I gave it mentioned that theta has to be in radians. So the first thing that I'd want to do is look at what is 135 degrees in radian measure. Well, 1 degree is the same as pi over 180 radians, right? So if I use that conversion formula and then simplify, 3 pi over 4 radians would be the same as a 135 degree angle. And so that's going to be my theta value. R is the radius of the circle, which in this problem is 30 feet. So when I plug in the information, I got 1/2 times 30 squared times 3 pi over 4 radians. And simplifying, we're getting approximately 1,060.29 square feet of the lawn is going to be what the sprinkler will hit there. Okay, so that is all I had for section 6.1. And here's the homework on page 372. Be sure to look at those problems when you get a chance.